Hi, my name is Denis Bouffard. I'm a product line manager in the Network Services Platform team, and today I'll be presenting automation and service fulfillment in industry networks. We'll cover briefly an overview of NSP. We'll discuss intent-based service activation and automation. We'll look at some new capabilities in network and service assurance, and also some new capabilities in terms of NSP deployment. First, an overview of NSP. NSP provides an open, programmable platform with a set of prepackaged applications for configuration and provisioning, for optimization and control, as well as assurance and analytics. NSP provides an open northbound API for integration into OSS systems or your own applications. Southbound, NSP supports and manages a variety of industry and government networks and technologies. Now let's look at intent-based service activation. Intent-based service activation is a new paradigm. The user defines the desired service outcomes. Those outcomes are automatically deployed into the network, and then also automatically audited and kept in sync. How is that achieved? It's a four-step process. First, the NSP Intent Manager application, which comes prepackaged with predefined service intent types for E-lines, VPLSs, VPRN, etc. Those are available off the shelf for use as is, or they can be customized to tailor your unique needs. Secondly, the service fulfillment or intent-based service fulfillment activation, we would create service templates using those desired service outcomes or intent types, and then define automation rules or workflows for each of these stages of the different life cycles of the service. Finally, using IBSF, or intent-based service fulfillment, the service creation team would actually create the services, deploy them into the network, and then continue to manage those services and the resources that those services are consuming. Finally, the operations team would use a variety of service assurance applications. There's KPI-based service assurance, for example, as well as dashboards and other applications. Let's look at service templates. The service templates allow you to simplify and customize the operational behavior. They provide a simple and intuitive mechanism, for example, to create a video service by simply picking a video service template. These service templates provide us a simple handle abstracting all the details that we see in the service definition. So let's look on the left-hand side at what the service definition team would actually be doing. First off, they'd give a service template a name. They would select the service intent type and version that applies to this particular service. They would choose a user interface schema, if you will, or a schema form for the configuration of the service. And where needed, they would select and apply workflows for the automation, the creation of that service. On the other hand, the service creation team, their job is a lot simpler. When creating a service, they simply choose the proper service template required, in this case, the video service template. Now let's look at the service activation lifecycle. With IBSF, we've added some additional states for convenience and simplicity. The first state saved, so the service creation team can edit, define, redefine, refine the service multiple times without reserving any resources in the network. Once the service definition looks appropriate, it can then be transferred into the planned state where network resources are actually reserved. Then perhaps at a later time, the service can be reviewed, approved by supervisor or other team members, and then the service can actually be deployed into the network and then converted to the deployed state. At this point, the service then starts to be audited automatically. If there are any issues, there is a misalignment state that the service transitions into, alarms are raised, and at any time, of course, the service can be modified and then redeployed. The service can later be removed if required. The removal state just implies that the service is removed from the network. It is not deleted from NSP. This can help avoid accidental deletions so that the service can actually be redeployed if needed. And then finally, when the service is no longer required, it's simply removed or deleted from the network. Through all of these steps and service transitions, we can trigger workflows whether the transition succeeds or fails. Now let's look at the user interface. So we can actually tailor what the configuration team enters into the service creation forms. If we see here, we can use the intent manager to hide fields and make them read-only, to modify acceptable parameter values or ranges. And as shown here, we could just simply change labels to fit the local terminology. For example, on screen 1, the default schema form, which comes prepackaged with the intent type, we see that an endpoint is called Site A. We can save the default schema form, give it a new name, in this case, Denis schema form, and give that a new label, in this case, head end. And then finally, when the service template is created and the user interface configuration form is selected, the service creation team can actually select the new Denis schema form with the new label, head end. Let's look at a sample use case here, one relevant to utilities, a teleprotection service. We see how intent-based service activation can help meet all these stringent requirements for this type of service. First, let's look at conventional service activation. With conventional systems, there can be many steps, many of them manual, involving CLI. This can result in a higher error potential. With IBSF, as we've seen, we have simple one-step template-driven approach. The service is kept in sync automatically with the audits as described, so we have a simple error-free operation creation process. What might that look like? So in this case, when someone selects create a service, they then step to select, in this case, the differential relay services template. So now let's look at the data that the user is presented with and needs to enter for the teleprotection service. So we can see here there's roughly 8 fields that have been selected in the service definition or the intent type, service template. Each one of these fields is been tailored specifically to the service type, so the jitter buffer, the choices to enable asymmetric delay control or network group encryption, et cetera, are on this form, as well as the endpoints. So for example, if ADC and NG need to be enabled, once checked, then additional parameters as required would be shown for the user to enter from the work order. Endpoints would be entered. For example, here we're showing 2 endpoints with select attributes that are appropriate to those endpoints. And once the service is created, we could see the service topology displayed in the application. We'll see later as well, there are a variety of service assurance applications that can help us maintain this service in peak quality. In summary, the intent-based service fulfillment provides these benefits for operational control, out-of-the-box intent types, as we saw earlier, with a complete lifecycle management and automated detection of service misalignments. It provides the flexibility to customize the presentation. It's also mediation agnostic, meaning that service activation can configure services for classic or model-driven managed networks. It's also ideal for networks of any size, large or small. Agility is also a key benefit. So at any time, we can add new service models. We can extend or modify the service models. We don't need to wait for the next release of NSP software. We could add or change or modify workflows at any time to slightly update or enhance the automation of service creation. Now let's look at service assurance. Service supervision, the web-based application, is the ideal starting point to manage the quality of services. So we could see on the top row visualizations in terms of KPIs, showing the health of each of the components of services, be it SAPs or SDPs, et cetera. And on the right-hand side, we can drill down to the root cause of any issues on those services. On the bottom, we could see that we could also troubleshoot starting with a topology view or the event timeline. If there are further changes that were made, for example, misconfigurations, they would appear here along with subsequent alarms. And then finally, we could, at any time, proactively trigger OAM tests to verify latency, et cetera, of the service. The NSP Network Health Summary Dashboard is also available and can also serve as a landing page. So as soon as an operator logs into NSP, they would see this overall network health dashboard. The first portion is shown on the left with the variety of KPIs indicating network and service health. There's also service impacted objects on the bottom, and then key alarms on the right-hand side in an event feed. As you scroll down the dashboard, you would see on the top right-hand side an end-to-end view of the topology in a graphical format, possibly a list of links or network endpoints with a time trend of utilization, for example. And then finally on the bottom, we could see an inventory of key assets, network elements, ports, et cetera, and their operational states. A new application has been added in 21.6 called NSP Indicators. NSP Indicators allows you to create custom KPIs that are meaningful and actionable for you and your business. With NSP Indicators, we can combine telemetry, be it gRPC, GNMI, SNMP or performance stats, or accounting or file-based stats. Combine those with the arithmetic operations you see here, as well as some unique aggregation functions that allow you to take a number of different data points and create a single KPI. We also have the ability to trigger automated corrective actions. So if we look at the diagram here, we could see a chart with two plots, one for a ring ingress utilization and one for a ring egress utilization. Looking at the chart, we could see in the center that we have two thresholds defined for these KPIs, a rising threshold and a falling threshold. Whenever the data point, or the KPI in this case, exceeds one of those thresholds, you see it presented on the data line, the blue line with a small circle. This indicates a threshold violation. At this point, a number of actions can be invoked. Either an event can be created on the Kafka bus, an email can be generated, or a threshold crossing alarm can be created, or all the above. It's purely a configuration option. So in this way, we could take an abstract concept, such as a ring, define a formula that combines the ports and lags that make up the ring, boil it down to a single utilization attribute or KPI, and then monitor that in real time and raise alarms or events, and of course then take actions as needed when the utilization is above or below threshold. Finally, let's look at some new NSP deployment options. So along with the standard software deployment of NSP on bare metal servers or in a virtual environment, the NSP appliance in 21.6 has been enhanced. So as we could see in the middle section of the slide, the NSP appliance actually combines at the factory a server, an NSP server, the Red Hat operating system, in this case, virtualization with KVM, and then a Nokia selection of software, of NSP software. And that selection in 21.6, we've added intent-based service fulfillment, as we've seen with the intent manager as well as the workflow manager. And we also have NSP analytics for reporting use cases, also as an option that can be added to the NSP appliance. So all of this on a 2RU server. If we look on the other side, the NSP server is a new product concept we'll be introducing in the fall timeframe, so aligned more or less with NSP 21.9. The approach here is to provide a server with a light integration of the Red Hat operating system, leaving you, the customer, the choice to deploy bare metal or virtualize with KVM or VMware, and to choose your own NSP software. Another benefit of the NSP server is its scale is broader than the NSP appliance. NSP appliance is limited to 1,500 to 2,000 network elements. The NSP server, depending on the modules chosen, could go much beyond that in terms of scale. In summary, we've seen how NSP, through intent-based service activation and automation, delivers simplicity, efficiency, agility, and quality. Thank you.